Okay, so let's try to have these further examples in finding the definite integral. Integrate 3 over 2x plus 1 from 0 to 3. Again, what are we going to do? That is now equal to 3 times, that is 1 over 2, the natural logarithm of 2x plus 1, and that is from 0 to 3. Right? And then just simply plug it in. Sorry, I don't have the space for this. So let me just put it here. Okay? So that is now 3 over 2. Then the natural logarithm of plug it in there, 7 minus 3 over 2, plug it in there, ln 1. Okay? So therefore you have here now 3 over 2 ln of 7, ln 1 is equal to 0. So this is the only answer that you have. Next, find the integral of this. The integral of this is the derivative of 2x is 2, reverse that 1 is 1 half. So 2 times reverse that 1 over 2, then e to the 2x, and then plug in from 0 to 2. So this is now e to the 2x only, then you plug it in here there. So that is now equal to e to the 4 minus e to the 0, which is equal to 1, or the final answer is e to the 4 minus 1. Next example. Differentiate x ln x with respect to x, or meaning find the derivative of x ln x with respect to x. Hence or otherwise, evaluate the integral of 1 over 4 ln x dx. So what we're going to do is just follow the clue. You need to differentiate x ln x. So use the product formula. So when you differentiate that one, that's the derivative of x is 1 times copy my ln x plus you copy your x times the derivative of your ln x is equal to 1 over x. So therefore that's equal now to ln x plus 1. So that is your x ln x. That is the derivative, okay? The derivative of x ln x is equal to this. Now, sorry, so visible there. Now, the question is, find the integral, hence, take a look, hence or otherwise. So find the integral of 1 over 4 ln x dx. So we're looking for the integral of 1 over 4 ln x dx. So let's see. 1 over 4, sorry, not 1 over 4, but integral of ln x dx from 1 to 4. So what we're going to do is to take to derive this expression from here. As you can see that ln x dx is this part, okay? So therefore, we can integrate all of this with respect to x, integrate all of that with respect to x, integrate this one with respect to x. And we need 1 to 4, so that is 1 to 4, that is 1 to 4, that is 1 to 4. Okay, then we can now extract this portion because this one now is similar to that. So therefore what we're going to do, the integral therefore, the integral of ln x dx from 1 to 4 is equal to the integral of this, of the derivative of x ln x dx from 1 to 4 minus the integral of 1 dx from 1 to 4. Okay? Now, if you got confused of the solution, then just pause the videos for a while and try to analyze it again. Okay? So again, this one, because you only want this expression here, so you put this to the left, then you have this one here. So, however, take a look that the integral of the derivative is actually the function, right? So let's that x ln x, that is from 1 to 4. Again, the integral of the derivative is the function itself, the one inside x ln x, from 1 to 4. Let's copy this one. 1 to 4 ln x dx. Then that is equal to what? This is equal to minus integral of 1 is x, so minus x from 1 to 4. Okay, so like that. So we can now simplify this definite integral. So plug it in there. So 4 ln 4 minus 1 ln 1 minus, let me put it in bracket like that, 4 minus 1. Right? So again, this minus is that minus. Then you plug in this one. So that's 4 minus 1. So ln 1 is 0. So there's now 4 ln 4 minus 4 minus 1 is 3. Therefore, that is the final answer. Okay, we still have time. So let's try to look at this next example. Differentiate 5x cubed ln x, hence or otherwise. Find the integral of this one from 1 to 3. So again, let's try to get the derivative of that. 5x cubed ln x. So we will take the derivative of that. So let's take the derivative of that one. And that's equal to the derivative of 5x cubed is 15x squared. Then you cover that times copy the ln x plus copy your 5x cubed times the derivative of ln x is 1 over x. Right? Then simplify that. What is that equal to? That is 15x squared ln x. And this one is 5x cubed. So that is plus 5x cubed. And that is the derivative of 5x cubed ln x. Okay, so the secret is that for you to be able to evaluate this one, you need to find the derivative of this. After finding the derivative, you need to make ways to be able to find this expression. Right? So we want this expression. So what expression do you want is with x squared ln x. Okay, that's what we want. 7x squared ln x dx. So among this one, this is the one with x squared ln x. So we want this expression. We want that expression. Okay? Because this one, okay, this one, maybe I will write here. This one could be written as 7 times the integral, 7 times the integral of x squared ln x dx from 1 to 3. So therefore, we want to get the expression. How are we going to get this one? So take the integral of that. Take the integral of that. This is with respect to x. This is with respect to x. Take the integral of that. That is with respect to x. And the boundary. That is from 1 to 3. From 1 to 3. From 1 to 3. Alright? So therefore, this one now is equal to what? So the integral of 15 x squared ln x is equal to the integral of the derivative of 5x cubed ln x dx, okay, like that, from 1 to 3 minus the integral, minus because this one will go to the left, minus the integral of 5x cubed dx from 1 to 3. Alright, now we want only the expression with x squared ln x dx. So this one going to be 1 over 15. Okay, 1 over 15. So maybe we can just divide this by 1 over 15, all of that. Divide this by 1 over 15. Okay? So, but however, we want 7 there. So, we need to multiply this by 7. So, therefore, well, let's multiply that one later. So, let's simplify this one first. So, again, the integral of the derivative will give you the function itself. So, there's 1 over 15 times the integral of this is 5x cube ln x. And you plug in from what? From 1 to 3. Minus 1 over 15. The integral of 5x cubed is 5x to the 4 over 4. And then you plug in, that's times there, you plug in from 1 to 3. Right? And then, again, this is only the integral of x squared ln x dx. Only this, okay? The 7 is not yet there. But only this one. So let's try to evaluate the integral now. So 1 over 15, that is 1/3. Then this you plug in. So that is now 1/3 of 3 cubed times the natural logarithm of 3. Alright, minus, then you plug in this, okay, 1/3 of 5 times 1, sorry, no more 5 here, 1/3 of 1 cubed natural logarithm of 1. So that is for that first term. Minus, let's simplify, there is 1/3 there. So there's 1/3 of what? 1/3 of times 3 to the 4th over 4 minus 1/3 of 1 to the 4th over 4. Okay? Next, almost there. So this is 3 cubed. 3 cubed is 27 divided by 3 is 9. So this is going to be 9 ln 3. Alright? This is ln 1 is 0. So minus 0. This one now is 3 to the 4 divided by 3 here. So that's 3 cubed. 3 cubed 27. So minus 27 over 3. 27 over 4 for that. And then this one is what? 1 over 12 plus 1 over 12. Okay? So therefore, that one now is equal to what? Again, this is only the integral of x squared ln x dx from 1 to 3. The 7 is not yet there. Okay, the 7 is not yet there. So we can multiply this by 7 later on. So therefore, what is this one there? That is now 9 ln 3. This is times 3 of that. 27 times 3 is 81. So minus 81 plus 1 there, minus 80 over 12. Is it right? 27 times 3 to carry 1, 81. Okay, so correct. So negative 80 over 12 divided by 4. So that's 9 ln 3 divided by 4. This one is 20 divided by 4 is 3. So minus 20 over 3. Then you multiply by 7. Because you have there times 7 in the original question. So you multiply by 7. 7 times of that, 7 times of that one. Okay, 7 times 9 is 63. So 63 ln 3. Then minus 140 over 3. Okay, so that one is the answer. Okay, I'm gonna cut this video for a while. I'm gonna give you more examples into further definite integral.